Volcanoes have always fascinated humans. Their sheer power is something we've feared and revered for millennia. But despite their obvious dangers, there's a hidden threat that comes from volcanoes that few people are aware of, one that can impact the entire planet. And it doesn't even come directly from the volcano itself. It's the stuff that's left behind, the ash. Hi, it's me. And this is our channel. In 2010, an earthquake in the early hours of the morning shook the residents of the Chilean town of Chaitén. Many assumed that the disaster was just a foreshock of a larger quake to come. Yet, they had no idea that what they'd felt was actually the result of a volcano suddenly coming back to life after being dormant for 500 years. The quake registered 6.2 on the Richter scale. It might not sound like much, but anything over 7 is considered major. Luckily, the town wasn't significantly damaged. However, the country's seismic watchdog agency, the University of Chile's Seismological Center, knew exactly what had caused the disturbance. A volcano some 50 miles away had just erupted. This volcano, known locally as Puncuti, sent an ash cloud 20 kilometers into the air. Authorities issued warnings to nearby towns such as Puerto Montt, which was 200 kilometers away. The cloud moved quickly in that direction, reaching the city within hours and blanketing it in a layer of volcanic matter 13 centimeters deep. At first, it didn't seem particularly dangerous. While the official authorities urged the 180,000 or so residents to stay indoors, they never issued a full-scale evacuation order. However, many locals did leave the city on their own accord. Images of cars stuck in thick ash showed the seriousness of the situation. As the cloud rolled through, it created a layer of ash so deep that it was impossible to see the road underneath. Within days, the problem became clear. Homes with thatched roofs suffered structural damage due to the weight of the ash. Harvests were ruined and livestock perished. Roads became impassable and vehicles broke down. Worse still, the ash started reacting with water to form a toxic sludge that seeped into homes and buildings. It was far from the first time something like this had happened. For centuries, volcanoes in Chile and elsewhere have posed a constant threat to human life. With more than 500 active volcanoes scattered across the South American nation, it's one of the most volcanically active countries on Earth. And while much attention is paid to the molten lava and rivers of fire that spill out of them, it's the fine particles suspended in the air that can pose the greatest danger. Volcanic ash is made up of tiny fragments of rock, glass, crystals, and other materials expelled from a volcano during an eruption. When mixed with gases and water vapor, it forms a cloud that spreads far beyond the immediate vicinity of the volcano. The most famous and deadly example of this was the 1815 eruption of Mount Tambora in Indonesia. The force of the blast was so great that it was heard 2,600 kilometers away, and the ashen gases blocked the sun, causing global temperatures to plummet by almost 2 degrees Celsius, leading to widespread crop failure and famine. More recently, the 1980 eruption of Mount St. Helens in Washington state killed 57 people. Although its lava dome only reached 14 kilometers into the sky, the cloud of ash it formed reached 32 kilometers. Fine ash traveled thousands of kilometers eastwards, eventually making its way to the Rocky Mountains, where it fell as a layer of grit. But if ash clouds can travel so far, how long does it take for them to get there? Well, it all depends on several factors, including wind speed and direction, altitude, and atmospheric pressure. During the Mount St. Helens eruption, scientists tracked ash particles traveling at speeds of up to 644 kilometers per hour. These particles could be carried more than 800 kilometers away in less than a day. And it's not just distance that matters. For instance, in 1991, Mount Pinatubo in the Philippines unleashed the largest eruption of the 20th century. Its ash cloud reached 35 kilometers into the atmosphere and spread around the world in less than 2 weeks. However, the cloud didn't consist of one single layer. Instead, scientists detected 4 separate pulses of ash, each traveling at different speeds and altitudes. Some moved horizontally at more than 500 kilometers per hour, while others rose rapidly through the troposphere before turning and heading northwards. To make matters even more complicated, Ash particles don't just drift along with the winds. They also fall straight down due to gravity. This means that while horizontal movement can carry ash thousands of kilometers away from its source, it will eventually come back down to Earth, sometimes days, weeks, or even months after the eruption. So when an eruption happens, scientists need to predict both the horizontal and vertical movement of the ash cloud to assess the damage it will cause. To do this, they often use computer models to simulate the dispersal of previous eruptions. By tweaking the settings, they can try to predict how far an ash cloud might go and how long it might take to get there. But these simulations aren't completely accurate, and relying on them can be a risky strategy. Consider the 2021 eruption of La Soufriere in St. Vincent and the Grenadines. Scientists predicted that the ash cloud would follow a similar trajectory to the 1979 eruption, which had reached Barbados, more than 170 kilometers away. But the 2021 cloud ended up traveling further, forcing many Caribbean nations to close their airports and putting millions of people at risk. That's because the actual behavior of ash clouds can be incredibly hard to predict. Even small changes in wind speed, altitude, or pressure can make a big difference. And while scientists have come a long way in mapping the paths of ash clouds, they still rely on luck to some extent. Even more concerning is the fact that once an ash cloud has hit land, it can cause all sorts of problems. Breathing it in can cause serious respiratory issues, especially for children and the elderly. It can also damage crops and contaminate water supplies. Ash clouds can linger in the air for months, making entire regions stuck in a volcanic winter. In some places, however, there is hope. Teams of specialists are working to find new ways to stop ash clouds in their tracks. One of the most promising techniques involves firing shells filled with water into the side of erupting volcanoes. The water turns to steam, creating a cushion of gas that slows down the rate of eruption and limits the size of the ash cloud. For now, though, there is no foolproof method of dealing with the aftermath of a major volcanic eruption. All we can really do is learn to live with the threat of ash clouds and hope that science will one day give us the tools to protect ourselves against them. But it's not just volcanoes that send out dangerous clouds of ash. Human activity is causing a different kind of airborne danger to float around the globe. For over 50 years, we've been pumping huge amounts of pollutants into the atmosphere. And one of the main culprits is the burning of fossil fuels. Coal, oil, and gas are made from the remains of ancient plants and animals. So when we burn them, we're essentially setting that stored carbon free. This extra carbon waste starts to trap heat in our lower atmosphere, possibly speeding up climate change. But it's not the only thing it's doing. Burning fossil fuels also releases sulfur dioxide, nitrogen oxides, carbon monoxide, particulate matter, and other chemicals into the air. These pollutants react with water, oxygen, and other substances to form secondary pollutants such as sulfuric acid, nitric acid, and ozone. Together, they form a toxic cocktail that hangs over cities and spreads across borders, affecting millions of people around the world. Take, for example, the 1 million or so people who live in and around London's notorious smog of 1952. After a cold winter, a series of high-pressure systems trapped smoke from coal burning in the city's industrial heartland. With nowhere to go, the smoke collected over the city, forming a thick, murky cloud. Visibility dropped to just a few hundred meters, and tens of thousands of deaths were linked to the event. While modern regulations have cut pollution in London and other cities considerably, the problem isn't over yet. Pollutants released into the atmosphere can travel thousands of kilometers before settling back down to Earth. That means that even if your local air is clean, you could still be breathing in toxins that started out in another country. What's worse, these pollutants can have all kinds of negative effects on human health. Breathing in large amounts of particulate matter, for example, can lead to lung disease and even premature death. And that's just for starters. So if you want to breathe easy, you need to know where the world's dirty air is coming from. Our latest video explores the sources of air pollution and what we can do to stop it. Thanks for watching.